Sean Assam.
Um,
He's there. You go, Assam. And you know what? That's probably not far from what I was going to say.
Good morning.
Good morning and welcome. Sean's going to talk with us a bit about Aquacal heat
Yes.
pumps, and we're going to go through those a little bit. He's going to take us through the ins and outs of that. Now, Sean, you and I, we've spoken a lot over the years, but I don't think we've ever met face to face. I don't know that we ever have we?
No, I don't think we have either. But yeah, definitely a lot of phone time.
Yes, definitely. So we both, Sean's another industry veteran. He's been in the industry. How long you been in the swimming pool world now?
35 years.
35 years. So he actually has 5 years on me. So I'm going to let him take over at this point. We're going to be talking about heat pumps. It's Sean Assam, and he's with Team Horner. So Sean, take it away.
Thanks, Rudy. Well, what I want to discuss, because I go in and out of the chat rooms and stuff, and I see some of the comments on heat pumps, and it's been long standing that when we get outside of Florida, the most common feedback that we get is that heat pumps don't work around here. So I just want to correct a lot of that information and go into a little bit of how heat pumps work, show you what Aquacal does and how Aquacal is different from other heat pump manufacturers in the industry. So I've got a little presentation that I want to run through, and hopefully that'll answer a lot of the questions. And at any point that you want to ask a question, please feel free to do so. And
yeah, if they have questions, they should just ask right in the comments on that Facebook post where this is being broadcast in the group. That's what I'm monitoring. So as I see questions there, Sean, what I'll do is I'll bring them to your attention. They're not very talkative this morning, and I know a lot of folks are out in the field, but the beauty of this is it's being recorded, and we will get to have a lot of folks take a look at it later. And then at that point, you can come back and check the questions as well.
Okay, great. So in my presentation, did I just advance a slide?
Say again?
On my presentation, did I just advance a slide? It says who we are.
Let me take a look and see.
Yeah, I'm not seeing it.
No, I'm still seeing your face. So I need you to actually go down and share your screen. Just like you would in a regular Zoom meeting, share your screen, and then everybody should see that. You should have permission to share your screen as well.
All right. How about that?
There you go.
All right.
All right.
So Aquacal has been around since 1981. We started a factory in St. Petersburg, Florida. We started off with about 2 buildings. We're up to about 12 buildings now. We have over 500 heat pumps sold nationwide. We have about 500 employees throughout the Team Horner umbrella, which is both manufacturing and distribution. We've got one of the best warranties and service in the industry. In the state of Florida, which happens to be our biggest marketplace, we do have about 14 service trucks. That's all employees that handle the service, the repairs, the warranties, aftermarket maintenance plans, all by our factory employees. And within the industry itself, we manufacture about a little bit more than a third of all heat pumps sold in the United States, and that includes the big 3 and some of the other small companies as well. We produce about 38% of all heat pumps sold into the industry. Let's see. All right, so it doesn't appear that my slides are advancing properly, or they're a little delayed. We're still on there, Rudy?
I hear you. Yes,
right.
I'm still hearing
so
you.
We've got one of the widest. Okay. We've got straight heat pump units only that are heat only. We've got some that are heat and cool. We have some that are chillers only. We've got commercial systems like the Great Big Bopper. And then we also have the geothermal, which are water source, and the SunPower are geothermal systems. So we've got an application for just about every need within the industry. Some of the features that we have that are different from other manufacturers is our smart microprocessor circuit board. The circuit board itself allows us to communicate with the electronic control systems like the IntelliTouch and the Hayward system, the Jandy system. So we can communicate with everyone's control system. We have a wide range of operating conditions. When we look at the factors that impact when a heat pump works and when it shuts down under protection, we have a different technology in how we actually monitor the operation of our system. A lot of companies will just look at temperatures, but we look at the refrigerant pressure as to whether it can continue operating or if we should shut it down under protection features. One of the big advantages also is our patented ThermoLink titanium heat exchangers. Now, titanium as a heat exchanger material is pretty much universal at this point, where everyone uses titanium. And the big advantage of titanium is that it's near impervious to any kind of chemical attack. Now, we know that with the Texas freeze, that it's not impervious to water damage and freeze damage. So, but the titanium itself will last under real harsh conditions.
Silly me, I hadn't thought of heat exchangers being lost in that
Yeah.
damage as well. I'm thinking, you know, pump housings, filters, and valves, and maybe some salt cells, but it didn't even occur to me. It makes perfect sense.
Right, absolutely. You know, and the housing itself is made of like a thermoplastic, so naturally the water freezing in there will expand and crack the tanks. But that heat exchanger design that we have also allows us a much lower flow capability. Now, this is more important with the trend of going to variable speed pumps and with regulations looking at limiting, you know, the higher horsepower pumps to variable speed pumps. So we're capable of operating under much lower flow capabilities. All right. Let's see. So our Hayward Super Quiet unit, which is our heat and cool unit. If you look at some of the specifications on here, now it's really important when you're looking at different heat pump manufacturers' designs. You got to look at the BTUs, and you have to look at like the second section down, which talks about COPs. The COPs is going to be a measurement of the efficiency of the system, coefficient of performance. So the higher the number, like you see on the SQ145, it's rated at a 7.1. So a 7.1 basically means that for each kilowatt of energy that you're paying for, you're getting 7.1 kilowatts of energy out, 7.1 kilowatts of heat going back to the pool. So it's a much more efficient design than gas heaters, electric resistance heaters. But when you're comparing heat pump to heat pump, the higher the COP, the more efficient and the less cost that's going to be to operate as well for the homeowner. So one of the things, if you look at the bottom, it says rated in accordance with AHRI standard 1160. Most of the manufacturers subscribe to this AHRI standard, which is basically a third-party testing organization. What they do is they test everyone's heat pumps to make sure that what we're promoting as BTUs output, especially at those 80, 80, 80, 80, 50, 63 are the two main parameters, that whatever we're promoting in our brochures is actually what they test and verify to be accurate, okay? Because what happens is there's a lot of manufacturers that do not subscribe, and their literature is based on whatever they want to put in there. It can be rated at a much different 80, 80, 80, 80, 90, 80, which is going to be your water temperature, ambient air temperature, and relative humidity. So they can play with numbers to show a much higher BTU rating than what it actually is in real life scenarios. So, you know, keep an eye on that with the AHRI standard 1160. But you can see on here that we've got a wide range of heat-only units, which are the first 3 units, and then the second, the other 2 units on the left, on the right side with the R after it, are our heat and cool units. All right. So the other thing to look at on this particular chart is the water flow rate, is that we require between 30 to 70 gallons per minute to operate. And within those, that flow rate, like I said before, our heat exchanger is capable of running at a much lower RPM on variable speed pumps, simply because of our heat exchanger design. And I'll go into that a little bit more. So the other features with the super quiet, now here's going to answer a couple of the statements that I see on Facebook, is that when it gets to a certain temperature, they just don't operate anymore. So with our super quiet heat and cool units, we'll operate down into the low 20-degree ambient air temperature, okay? Now, it's true that when you start getting into colder ambient air temperatures, that your BTUs will drop quite significantly, but instead of shutting down, our heat and cool unit automatically goes through what we call a hot gas defrost, so that typically around the unit itself, you have an evaporator coil, which is basically like a car radiator. When you get a lot of condensate on the evaporator coil and cold water temperatures, there's a tendency for that to turn into ice. All right, so when it turns into ice, it blocks the airflow going through there. Our hot gas defrost is going to send hot gases through there, melt down the ice, and then go back into heating mode again. So it's going to continue doing that until it gets down into the low 20s. Again, you will lose BTUs under those conditions, but it will continue to operate. When we look at the regular heat only on the super quiet units, we'll operate down into the low 40-degree ambient air temperatures and still create some heat for that homeowner, okay? Corrosion-proof plastic cabinets, we mold them in St. Petersburg instead of looking for an outside source. And with the super quiet unit, we do have the quietest heat pump models out there. It's a 55 decibel rating. Now, on a 55 decibel rating, it really doesn't mean much to anyone as to what that is. But when we look at 55 decibels, it basically adds no noise to the equipment pad. And in real life scenario, if you're standing 10 feet away from the unit operating, it's very silent. You cannot hear that it's operating until you walk up and see the fan moving and feel the airflow coming out of it. So for zero lot line homes, or for equipment sets that are right by a bedroom window, with the patio area, the super quiet is very beneficial for those type of environments, okay? What's new from AquaCal? We have introduced over about a year ago our variable speed heat pump. Now, what the variable speed heat pump does, just like a variable speed circulation pump, it adjusts the speed of the compressor and the fan automatically. All right, so it's all based on what the heat demand is of that particular pool. We're constantly testing and adjusting the speeds of the unit. Now, my recommendation with this particular heat pump is use it with 15,000 gallons or smaller. And the reason why I say that is because if it's greater than 15,000 gallons, there's a tendency for it to run on high speed all the time. So there's really no benefit to running at high speed with a variable speed pump if it's always in high speed. So the variable speed pump, as your temperature gets colder, the speed of the fan and the compressor slows down. And as we know with circulation pumps, when it's running at a slower RPM, your cost savings are quite significant. So that's the benefit of the AquaCal Super Quiet system. In our lower model lines, if you have good, better, best, the good line is going to be our Tropical units. And our Tropical unit is basically going to be a lower price, a little bit louder than the Super Quiet, but it gives you all the benefits of the Thermalink heat exchanger in regards to the flow rates. And you can see on here, we have, these are just heat only, but if you look at the COP, they're not as good as the super quiet units, but they're still pretty good, because like a T90 unit, you're getting a 6.0 return on the COP, the efficiency of the performance. All right. Same thing with the flow rate. We're at 30 to 70 gallons per minute. And if you notice on the two smaller one, the T55 and the T75, we use a different heat exchanger in that one. So the flow rate is going to be 20 to 45 gallons per minute on those particular units. And I'll go into the different heat exchanger designs also in a minute. As you can see on the Tropical, we will operate down into the low 40-degree ambient air temperatures also. And then what I wanted to talk about too is there's a lot of response in regards to the humidity. heat pumps are a Florida marketplace because it's very humid there. Well, I'm here to tell you that Florida is our biggest market because that's where we manufacture our products. But our second biggest marketplace is going to be up in the Northeast United States. We can operate at lower humidity. Our third biggest marketplace is going to be in the Phoenix area. All right. So someplace that's completely as dry as can be operates really well with our heat pumps. Now, other places like Las Vegas and Palm Desert, we're starting to ship products out there into distribution. So I think that even distributors and the pool dealers out in those dry, humid areas are realizing that, yes, AquaCal does work in those areas. All right. So when we look at the factor of what humidity plays into the operation of a heat pump, it does affect it a little bit, but not as much as the industry thinks. So can we operate under low humidity areas? Absolutely. Absolutely. All right. So if we look at heat pumps, we can kind of describe it as a collector of solar heat from the air. So it's a mechanical collector of solar energy is a better way to put it. And the way that a heat pump works is, we are about 400 to 700% efficient, which ties into that COP, the coefficient of performance, right? Unlike other methods of heating a pool, we know that BTU is a BTU is a BTU, whether you get it from a solar panel or you get it from a gas heater, electric resistance, or a heat pump, a BTU is a BTU. Now, what's different as a fossil fuel gas heater are typically between 80 to 90% efficient. You've got some units that are a little bit higher efficiency, about 93% efficiency. But what that means is that for every dollar of heat that you're burning to create the heat, or fuel that you're burning to create the heat, you're only getting 80 to 90% of heat into your pool. And the perfect example is when you stand around a heat pump, you feel all the heat that's emanating from the heat, or I'm sorry, when you stand around at the gas heater, all the heat that you feel emanating from that gas heater is wasted heat that's not going into your pool. All right. So they're not 100% efficient. You are burning fuel to create heat, but some of that heat is being wasted away. When you look at an electric resistance heater, they're 100% efficient. But when we look at the amount of BTUs that 1 kilowatt produces, 1 kilowatt produces 3,412 BTUs of heat. So your typical 11 kilowatt electric resistance heater is going to give you a little less than 40,000 BTUs of heat. All right. And when we look at a heat pump itself, our biggest heat pump is going to run at maybe about 6.5 kilowatts of electricity. So with 6.5 kilowatts of electricity, I'm going to give you about 135,000 BTUs versus 40,000 BTUs on electric resistance heater. All right. So that's some of the differences. Now, how does a heat pump work? Basically, cold water in. We're going to draw the ambient air temperature through the evaporator coil, and we're going to feel cold air coming out of the unit. Warm water goes back to your pool or your spa. So a quick way to see if the heat pump is working properly is feel the air temperature that's coming out of the heat pump itself. And it should be about 7 to 10 degrees colder than what your ambient air temperature is. And that's a good indicator that the unit is working properly. Another thing is you're going to see a lot of condensate water coming out of the unit. So basically what that means is that we're absorbing the heat out of the air and we're discharging the cold air back out of the unit itself. So we're transferring that heat. Like I said, we're mechanical transfer of solar energy to your pool water, okay? Internally, how it works is if we look at the bottom purple line going across, we've got cold liquid refrigerant, all right, that's going through the evaporator coil. The fan on the top, what it's doing, it's drawing the ambient air temperature through that evaporator coil. And when we draw a little bit of heat through the evaporator coil, it takes very little heat to transfer that liquid refrigerant to a hot gas. Okay, so after the evaporator coil, we've got a hot gas that's going to go through the compressor, and it's going to super compress it and make it even hotter. At that point, it's going to go through the heat exchanger to where your pool water is mixing in with the refrigerant through different coils. And we're going to strip the heat out of the refrigerant and go back to your pool or your spa. So basically, when it strips the heat out of the refrigerant, it goes back to a cold liquid refrigerant stage. So what does a heat pump do? It basically takes the nature of HVAC refrigerant and transfer it from a cold liquid to warm gas to super hot gas going into the heat exchanger. And that's the efficiency of the system. We're only spending electricity to spin the fan and spin the compressor. We're not burning fuel to create heat, okay? And that's why we're so much more efficient, is because the nature of HVAC is such that it takes very little heat to absorb a lot of heat out of the air, okay? Heat exchanger design. There's a couple of different heat exchanger design, and the one on the bottom is our ThermoLink patented heat exchanger design. When you look at the tube and tube design on the top in this particular picture, you can see that there's very little free flowing of the water going through there. So it's very restrictive. And when you're dealing with variable speed pumps, it's definitely going to add into your back pressure, into your circulation system. So when we take that and we look at the design of the ThermoLink heat exchanger, it's a patented design basically because we've got a dual heat exchanger going inside there, to where your water's going in one direction, your refrigerant's going in the opposite direction, so that we can optimize the heat transfer from the refrigerant to the pool or spa water itself. And that's the nature of our heat exchanger design. All right, so titanium has long been a product that has not been very efficient, but it does allow you a good heat exchanger transfer. So when we look at designing our heat exchanger, it wasn't until we had this design built up and tested before we actually released our titanium heat exchanger. So there are a lot of heat pump manufacturers that came out with their titanium heat exchangers before we did, because we had to test it to make sure that we had the best unit out there. So when you look at this diagram, the internals of the unit, when you take the top water flow coming in, all right, so we've got the water coming in, and you can see those other coils right there are going to be the refrigerant coils. So the water's passing through and touching the coils all along the way before it goes through and then cycles back out. And what that means to us is that we've got optimal transfer of heat, because the coldest part of the water is touching the coldest part of the refrigerant, all right? The hottest part of the water in the center is touching the hottest part of the refrigerant where it comes into the heat exchanger. So all along the way that the water's passing through the heat exchanger, it's picking up heat, and that's what I'm talking about. If it were to go the opposite direction, with the cold water hitting the hottest part of the titanium coils, it's not going to be as efficient as the design that we have here. On sizing, there's a couple of things that we need to know about heaters. All right, doesn't matter, like I said, if it's a gas heater, solar heater, electric resistance, or heat pump. When you look at the middle there, 1 BTU heats 1 pound of water, 1 degree Fahrenheit. That's the basis of all heating calculations as to when you say, well, how long is it going to take to heat it up, or how many hours a day is it going to run to maintain the temperatures. For a heat pump manufacturer, the important part for us is maintaining temperatures. Okay, so the efficiency is maintaining the temperatures. So it's really how many hours a day is it going to run to make sure that we're keeping the correct temperatures. Here's a couple of things. Well, let me jump over to something real quick. Stop share. I want to go into the easiest way to size up our systems. All right. And if you go to our website, aquacal.com, go to new share. Okay, so on the aquacal.com website, you can click onto our sizing program. And in our sizing program, it is specific to the state and the city. So if we took, say, Georgia, and we go to the Atlanta area, what you see are these average temperatures popping up that gives us the average temperatures for the months for the last 25 years. And basically, if you see on here, we've got 3 months that are showing in red. Those are going to be the months that are challenging for us to try to maintain temperatures. So if we click on second half of March, and let's go to beginning of November as our operating season. Now, you can tailor this to exactly what the customer wants or what you want to evaluate as far as sizing. And over here, you'll see that this temperature actually is calculating to maintain 80 degrees pool water temperatures under the coldest time of the year. All right. The numbers with asterisk is basically looking for you to just putting something, and then we'll go to step 2. And step 2, oops, let me go back to air source. In step 2, we're going to put in the parameters of the pool. So let's say we've got a 18,000 gallon pool, average depth of 4.5 feet, not a windy condition, and 60 hertz. We can select the type of heat pump we want to go with. We can either go with a super quiet, or we can select the Tropical units. Let's go with the super quiet unit. Now, what this is doing also, it allows us to calculate based on if they use a blanket, if they use an aqua blanket, which is one of those liquid blanket solutions, or if they're not using blanket at all. And under those conditions, we can plug in the unit that we want to consider. So let's try the SQ166R. It's telling me 5.4 hours per day of operation to maintain 80-degree temperature. If we use that same unit with the aqua blanket, 8 hours a day, and an unblanketed pool, it's showing me 13.4 hours a day. So with any of those scenarios with an 18,000 gallon pools, I can use an SQ166R successfully and maintain 80-degree temperatures within those months that I've selected. We can go one step further if they want to see, well, how much is it going to save me versus a gas heater? If we select either the natural gas or the propane gas, let's go propane, and let's use a price of $3 a gallon for propane and 12 cents for electricity. All right, so based on those parameters, what I'm going to do is generate a cost comparison, and then it's going to tell you, and this is a great tool to show the homeowner, that based on, let's look at the 5-year return, you get an 86.47% cost savings going with the Aquacal heat pump versus a gas heater. So in 5 years, they're going to save about $18,000 worth of operating cost of, gas versus if they were to go with our heat pump. And then you can look further down here, it breaks it down to the monthly operating cost on average, okay? So this is a great tool to size up, but also to show the homeowner, what the cost savings are. Now, you can custom tailor it to exactly what they pay for propane or natural gas and what they pay for electricity, and it will give you a printout to show you what the different cost savings are. So it's a great tool to use out with the homeowners, or if you want to do it in advance and then take it to the customers, it's a great tool, again, to show them how the system works. All right.
I found that to be one of the, sorry, I didn't mean to interrupt, but I found that to be one of the best closing tools you possibly can have when talking with a customer about a heat pump, is to actually have legitimate numbers based off of their electrical consumption and show them savings. So that is a fantastic tool to have.
Right, because it makes it more real to them. You're going to use the numbers that they tell you is what they pay, and then you can do the cost comparison. Now,
it's always the big question: how much is that heater, and how much is it going to cost to run? And about half the time, you get the answer to the how much is the heater, but then as far as how much it costs to run, a lot of times folks, hesitate and hem and haw and don't want to give out a real number because they, just aren't comfortable.
They don't know how to calculate it.
Yeah,
right.
So this is fantastic.
Right. So now the other thing too is okay, so now you're considering they don't have a heater at all, but they want a heater. Now, is it best to put in a gas heater? Gas heater is going to be cheaper up front, but now you got to run the gas lines. Now, with a heat pump, with a lot of older homes, they may not have the power there. So now they got to consider, well, how much is it going to cost to run, a bigger box or run the power lines out there? And in most cases, it's a wash. So a heat pump is going to be more expensive than a gas heater, but a lot of times the cost to run the gas lines out to the equipment is more expensive than having an electrician come in to upgrade the panels, you know. So, you know, when you look at that part of it, the initial cost, you know, could be about the same, but the operating cost is the important part of it, to where it costs them a lot less to maintain their pool. Now, we like to say that when you put in a gas heater, what typically happens is that they run the pool and the gas heater. It's great until they see that first gas bill. And after that, it's basically shut that heater off until we know we're going to be using the pool. The big benefit with our heat pump is that you can actually maintain temperatures at a very cost-effective price point, so that the pool is always ready for them to utilize. Okay. Getting away from heat pumps a little bit for the heating option, we've got a lot of commercial installations that are looking to keep the heat out of the water, especially over the summertime. These two particular jobs of St. Louis Country Club, Houston Country Club, went with our big commercial Great Big Bopper. Now, these happen to be heat and cool units also, but they wanted it for the cooling features, because the swim team over the summertime in both these locations, water temperature was getting up into the low 90-degree water temperature. So with our Great Big Boppers in the chilling mode, we're able to bring it down to about 82 degrees for them, which is much more comfortable for the swimmers. All right. So when we look at some of the other options, as well as just chilling, let me go over. We have chiller-only units. Now, with our chiller-only units, these are designed more for, you know, the residential marketplace, so that we can take the heat out of the pools over the summertime. Texas is our biggest marketplace right now for the Tropicool chiller-only units, and the reason why is because it gets hot over the summertime. The complaint is my pool feels like a bathtub, right? So with the Tropicool, it is a heat pump design, which is designed to take heat out of the water, so we can make it much more comfortable. Now, there are other chillers in the marketplace. The biggest difference is that our unit is proven technology, to where we can operate even when it's very hot outside, or if it's humid, or if it's dry. Those really does not impact the ability for our system to cool off the water. If we look at the chart here, the easiest way to take it is we've got 3 different size chillers. Look at the chart on the right side, look at how many gallons you have, and then determine how much temperature you want to take out of the water. That's the easiest way to size this. There's no sizing program on the AquaCal website. Just use the chart itself. All right. Where chillers are also becoming very, very popular are for these, you know, the upper end athletes, because just as you can recall with football players, after big warm up or, you know, practice day, they go back to the training room and they dip themselves in this big trough of ice water. That's cooling themselves off. Now, the reason why they do that is because chillers, or chilled water, is the most efficient way to help with muscle recovery, okay, from fatigue and all that stuff. So for tennis players, these high-performing athletes that work out every day, this is one of the best things that you can offer to them. If they've got a hot tub, we can isolate the hot tub and put the chiller on there and drop that water temperature down to the 40 degrees temperatures if that's what they want. All right, so it's another option to consider. Now, heat pumps will produce a lot of condensation. Okay, so the big question is, I think my heat pump's leaking. Well, the best way to check that out is, like the bullet point says, heat pumps can produce up to 9 gallons per hour of condensate water, depending on temperature and humidity. So where does humidity come into play? If it's really humid, you're going to have a lot more condensation. Okay, but an easy way to check and see if it's leaking or if it's just condensate is check your pool for chlorine. Check that condensate water, the water that's around the heat pump, for chlorine. If there's no chlorine in the water coming out of the heat pump, it's all condensate. All right, that's the easiest way. Another way is just turn off the heater. If it stops with the condensation, then you know that that's what it was condensation. AquaCal does offer, you can see on the bottom right-hand corner, a condensate drain kit, which will attach to all of our units. You basically plug off one side, attach it to the side that you want to drain that water out to, and then you can actually run it out to a drain field, so it's not making your equipment pad all wet. Okay, so it's taking it out away from your equipment area. Another type of a heat pump that we manufacture are geothermal, which is a water source heat pump. A geothermal can be installed inside or outside. It produces no noise at all. It basically has two heat exchangers on the inside and the compressor. They can be stacked on top of one another. So if you've got a small equipment room, you can definitely stack these units on top. There's no emissions, and will operate down to 45 degrees source water. Okay, so what it basically does, if you look at the bottom picture, you've got two lines for your pool or your spa, and then you have two lines for your source side. And the source side basically typically would be a well. It could be a big lake. In some cases, what we've done is we've used pool water to heat up a spa. Okay, so we've done that very successfully. And again, with these type systems, we do have titanium heat exchangers. So especially with commercial spas where water chemistry is pretty much always kind of bad because it's eating up heat exchangers. Especially if you've got electric resistance heaters on those, you're probably seeing deterioration on those heat exchangers constantly. So by going to a titanium heat exchanger that we have in our units, it'll last much, much longer without any kind of repairs needed. Okay. Holiday Valley Children's Center, the ski resort, we've used this very successfully. As you see in the picture, we have two spas outside. You've got an indoor-outdoor pool that's heated with your traditional boiler system, and it's a ski resort. So the picture on the right-hand side shows the spa itself with steam coming off of it and the snow all around it. Basically, what we've done is we've utilized the pool water as our source to keep the spas heated up. And those, like I said, the spas are outdoor. There's a video online. If you look up AquaCal Holiday Valley, you'll see an interview with the operator of this facility talking about how successful it is, and they're using our autopilot salt systems on these bodies of water as well. But it's a great application for spas on commercial projects where you can utilize their pool water very cost effectively to keep the spa heated up. Commercial options, again, our Great Big Bopper. It's 500,000 BTUs of heat from a single heat pump itself. We're doing a lot of these systems on these bigger commercial projects. And like I showed you before, with the country clubs to where they're looking at taking the heat out of the water, the Great Big Boppers is a great application, a much smaller footprint to be able to produce either heat or to chill the water out. As you see on here, these are all three-phase, but in the 60 cycle, it's 527,000 BTUs that we're producing from these units. So they're big units, a lot of BTUs, largest heat pumps out there. Lynn University in Boca Raton, Florida, their particular system needed 3 of the Great Big Boppers. And this is how you would install multiple Great Big Boppers. In the past, this is how we would have to install the smaller systems, just a whole bunch of smaller heat pumps stacked up. So you can see the difference between this type of application where you've got the much larger Great Big Boppers versus the smaller units. It's a smaller footprint, much easier to manage, much easier to plumb in. All right. Also new from AquaCal is our pool sink system. With all of our heat pumps, I described before, the HP9 circuit board, it's a smart circuit board. We're capable of connecting to our pool sink system. Now, what the pool sink system does is it connects with the heat pump and talks to it by way of the Wi-Fi and your Wi-Fi app. Okay, so on your phone, you would download the application. On your Wi-Fi, you connect to the antenna, and now remotely, you can adjust temperatures. Now, this is good for both commercial systems and for the residential systems, but you're able to adjust the heat pump itself to change water temperatures. You can put it into heat mode, cool mode. You can shut it off from the unit. You can see exactly what phase it's in, if it's working properly, all remotely. And it's a very, very nice price point that you can offer to the homeowner. Something like this on the retail side would be about $250, and it does not need any kind of electronic control system. So for a property owner who's looking at their heat pumps, they can go on their phone and adjust temperatures if they need to. They get that complaint call saying the pool's not hot enough. Well, let me look at my app and see exactly what temperature it is. And, they can make a determination if they want to increase it or not. So it's a real cost-effective option for all of our heat pumps. Okay.
Your
So
timing is pretty perfect there. So right now we have a couple of minutes left, Sean. So if there's anything that you want to leave everybody with, if there's any message, any contact info, how do we get a hold of you? And but before you answer that, I just wanted to say really quick, we are broadcasting live in about 12 different groups across Facebook. So with that, we deal with whatever internet issues we have, but with that, I can only monitor one place if you have questions. So what I'm looking at right now is the Pool Operator Talk News page. It's a page, the link is right above what you should be seeing, but click on that, ask your questions there in the comments, and then that way I can see them and get them to the speaker. I can't monitor 12 different groups. But with that, Sean, what do you want to leave us with? How do we get a hold of you, buddy?
My email address is Sean, SEAN, at teamhorner, HORNER.com. My cell phone number is 954-325-3859. My phone is always next to me and on. So if you need to get a hold of me, that's probably the quickest way. If you email me, I'll usually get back with you the same day, but a lot of our resources is on the aquacal.com website, where we've got tutorials, we've got troubleshooting videos, a lot of resources on there. So take the time to look at our Aquacal website. And again, for those who don't think that heat pumps work anywhere in the United States, I'm here to tell you that they do. They work everywhere in the United States. All right. Rudy, thank you so much for the opportunity. And
Oh, no,
I'll be
Sean,
back later
thank
on
you.
with the autopilot.
Thank you. Yes, we will see you again later today. Toward the end. Well, actually, you're going to wrap it up for us with the autopilot, correct? But right now, thank you for taking time out of your day to talk with us. We really appreciate that. And everybody, big thanks to Sean Assam, and I got his name correct. So now we're going to give